Alright, this video is for pH of salt solutions. And there are different types of salts. Sodium chloride would be an example of a neutral salt. Ammonium chloride would be an example of an acidic salt. And the way to predict this would be to say what base and what acid are used to make ammonium chloride, and it would be made from HCl and ammonia. And you take the strong one, which is HCl, strong acid, and then from there you say it would give you an acidic salt. So it's just in a way to remind you, or to kind of trigger your thinking. If it's made from a strong acid, then the salt will be acidic. Sodium cyanide is an example of a basic salt. So one way to think about this would be the acid and base from which it's named, or from which it's created, sodium hydroxide and hydrogen cyanide. So which is the strong one? Sodium hydroxide. So that will make the salt basic. It's just a way to think about it. And then ammonium cyanide. In this example, you're not sure because this is made from ammonia, that's an N, ammonia and HCN, and neither are strong. So here you would just say it depends. And leave it at that for the moment. We'll analyze that in a bit. All right, so then we want to look at each of these four and analyze the pH. The first one would be sodium chloride. And the trick here is to start with the salt, put it in water, and let it dissociate excuse me, into ions. So the first step is that it just breaks up into ions. Second step would be to take each of those ions and to ask the question, will water become hydrolyzed in the presence of the ion? So will sodium hydroxide be formed and H plus, and will chloride, everything here should be aqueous, form HCl plus hydroxide. So you're asking the question, can it happen? And the answer is 100% no, because sodium hydroxide is strong, HCl is strong, 100% in the opposite direction, and so you'll get 100% dissociation. These reactions will not occur, and so when it goes into solution, you'll have 100% sodium ion and chloride ion. Therefore, you've just got sodium ion, chloride ion, and water present upon mixing, and you assume that those two ions have no effect. They're just like spectator ions in water, and so the pH is the same as the pH of water. The pH for the solution is going to be 7. So that's a neutral salt, giving a neutral solution, neutral pH solution. Alright, then one, which is ammonium chloride. And for ammonium chloride, we do the same thing. We start with the solid, we put it in water, and let it break up into ions, NH4 plus and chloride. Step 1. Step 2. So step 2 is to say, or to ask, what will ammonium do in the presence of water? And what will chloride do in the presence of water? So ammonium will hydrolyze water. Actually, it doesn't hydrolyze water. The proton from ammonium will add to water. So you're going to have NH3 and hydronium. So this reaction will occur. And the second one, we say there's no reaction based on the argument in the last example. No HCl will be formed because HCl is a strong acid and wants to be 100% associated. So there's no reaction here. So we go ahead and rewrite now the reaction for ammonium. I'll leave out the phases here, but I'm not leaving out the charges. Okay, and let's look at a calculation for pH, and let's say that we have a 0.1 molar solution. And it's always a situation with the salts that you have the conjugates. So this is the conjugate acid of NH3, ammonium, and so we need to get the Ka value. And the Ka value for ammonium is calculated from Kw. So we have Ka for NH4 plus is equal to 1 times 10 to the minus 14 divided by Kb for ammonia, which is 1.8 times 10 to the minus 5. So this is 5.6 times 10 to the minus 10. That will be equal to x squared over 0.10 minus x. And then we have x being equal to the H3O plus concentration, and that is equal to the square root of 0.10 times 5.6 times 10 to the minus 10, and that is equal to 7.48 times 10 to the minus 6. That's 6. And then we get that the pH is the negative log of that, which is 5.13. So it's an acidic solution, pH 5.13, and we predicted that it would be acidic because ammonium chloride comes from a strong acid and a weak base. Alright, next we can look at sodium cyanide. Put it in water. It'll break up into sodium plus cyanide. And that would be step 1. Step 2 would be to look at each of the ions and ask, will they react with water? The answer for sodium is going to be no reaction. For cyanide, the answer is yes. It'll form HCN. There'll be an equilibrium to form the weak acid, HCN. and then you get hydroxide as well. And this is all aqueous. I didn't write that down, but it is. So let's go ahead and do an ice table for this one and calculate the pH for a 0.1 molar solution. And here cyanide is the conjugate base. We need Kb. So Kb is 1 times 10 to the minus 14 divided by Ka for HCN, 4.9, 10 to the minus 10. And so Kb for cyanide, 2.04 times 10 to the minus 5. Then we'll say 2.04 times 10 to the minus 5 will be equal to x squared divided by 0.10 minus x. We can drop the x in the denominator here. Excuse me. And then say x is equal to the hydroxide concentration, which is going to be equal to the square root of 0.10 times 2.04, 10 to the minus 5. And so the OH minus concentration equals 1.43, 10 to the minus 3. And let me see if I can shrink that a little bit. Yep. So the POH equals 2.84. 14 minus that is the pH, and that is equal to 11.16. So we predicted that the sodium cyanide salt solution would be basic based on the idea that it's made from a strong base and a weak acid, and that turned out to be the case. If we looked at ammonium cyanide, so NH4CN solid in water, it would break up into NH4 plus cyanide. And here, as I said, it just depends because you've got the conjugate acid ammonium and the conjugate base cyanide, and it's going to depend on the values of K for these. And so go ahead and look at the steps, and you've got ammonium plus water forming ammonia plus hydronium, and you have cyanide plus water forming HCN plus hydroxide. You know that Ka for NH4 plus is 5.6 times 10 to the minus 10, and Kb for cyanide is 2.0 times 10 to the minus 5. Alright, so you're going to take the larger one here. That is the one that will have the most significant impact on the reaction with water in solution, which means that hydroxide will be in higher concentration than hydronium. And we're saying here that Kb is greater than Ka, therefore the solution will be basic. and we've already done the work on the cyanide solution. For a 0.1 molar solution, the pH will be 11.16. Alright, that's the end of the discussion here.